Hello everyone. So today we are going to discuss the PFQV control loops in the power system operation control. So today we are going to discuss about the PF and QV control loop. So PF is nothing but real power, P is nothing but the real power, S is nothing but the frequency, and for Q is nothing but the reactive power, V is nothing but the voltage. So P and F both are the dependent parameter, Q and V both are the dependent parameter. Okay, if the real power is changed means automatically the frequency also changed. If the reactive power is changed means automatically voltage is changed. So normally in the power system operation control, so our main objective as a electrical engineer in the power system network, and the electrical role of the electrical engineers to maintain the voltage profile within the specified limit, voltage level within the specified limit, as well as to maintain the frequency within the specified limits. Okay, normally for the as per the IEEE standard, the tolerance value of frequency is plus or minus 3%, and similarly for the tolerance value of the voltage, so plus or minus 5% for the, so that is why it's low voltage, and plus or minus 10% for the high voltage. Okay, so as a engineer we have to maintain these two parameter within the specified limit. So why you have to maintain these two parameter within the specified limit? So all the electrical components, okay, so that is the manufacturer, that is component are designed based on the rated voltage and frequency. Okay, so beyond that this value, so what happen? So suppose if voltage is increased or decreased in the tolerance value, or the frequency is deviated from the tolerance value means, so what happen? The lifetime of the equipment, it will be going to reduce. Okay. So on then protected devices connected in the transmission line side, it will be energized, or it will be tripped the circuit. Okay, it will produce the maximum trouble in the transmission network. So the role of the engineer, so you have to maintain the frequency and voltage within the specified limit. Okay, so in here in the PF and QV control loop means, so these P and F, real power and frequency, are the dependent parameter, and reactive power and voltage are the dependent parameter. Okay, and similarly frequency and reactive power, or in real power and reactive power, frequency and voltage, these are the independent parameter. Okay, so how we have to control this real power and voltage? Okay, see this diagram. So here, so this is nothing but the generator. From the generator we have to generate the power. Okay, so before that what will happen? Here we have the generating station. Okay, with the help of the turbine we have to generate the power. Okay, in the generating station, so we have the that is why it's a turbine and the generator and all. Okay, if consider here it's a thermal generating station means, so this is called the valve. So through the valve we have to permit the high pressure of the steam. So this high pressure of the steam, what happens? It will be strike the turbine. So the turbine will be start to rotate. Okay, so the turbine shaft and the generator shaft. Okay, here this turbine shaft and the generator shaft, it will be couple each other. If the turbine start rotate means automatically the generator also it will be start rotate. Okay, so and then, so in the generator field, through the separate excitation system, we have to give the supply to the generator field. Automatically it will be energized. Magnetic field will be created. Okay, this rotating armature conductor cuts the flux lines automatically based on the Faraday's law of electromagnetic induction principle. The EMF induced. Okay, it will generate the power. So the generated power, it will be given to the transmission line side. Okay, see here. So the generated power have to transmit through the transmission line side. So here with the help of the voltage sensor we have to sense the voltage level. Okay, and with the help of the frequency sensor we have to sense the frequency level. Okay, for example in the voltage sensor we have to sense the voltage. Okay, and then that is we have to compare with the actual voltage. Okay, normal voltage. With the help of the automatic voltage regulator. Okay, we have to regulate the voltage. Okay, here I have to compare with the actual voltage with the desired voltage. Okay, based on that I have to change the excitation system. Okay, you have to increase the voltage level, or you have to increase the excitation or decrease the excitation. Based on that, here the generated voltage it will be increased or decreased. Okay. So this is for the control of the real power, reactive power and voltage. So and then this side, for with the help of the frequency sensor, we have to sense the frequency level. Okay, so that is we have to, with the help of the power controller and in the transmission line. Normally in the all the transmission line it will be interconnected. Okay, so based on that, the change in combined signal based on the frequency level. Okay, you have to identify the error. Okay, change in frequency you have to calculate. On based on the change in frequency, you have to give the commanding signal to the valve. Okay, so here it's a valve control mechanism. So you have to open the valve. Additionally means the high pressure of excess steam it will be strike the turbine. Automatically the turbine speed is increased, power generation is increased, frequency is increased. Okay. If the frequency is increased beyond the non-rated value means what happens? So here control the valve, have to close the valve, reduce the valve, automatically the flow of steam through this valve to the turbine will be reduced, automatically the turbine speed is reduced, power generation is reduced. Okay, so we know that N equal to 120 F by P. Okay, speed N and F is both are directly proportional. Okay, speed and frequency both are the directly proportional. Okay, so based on that I have to control the real power and frequency, and then I have to control the reactive power and voltage. So this is the concept of the real power frequency or PFQV control loops. Okay, thank you.